So here we go. If you're writing this on a piece of paper and you don't have the template, what you need to really have written down is converse of corresponding angles postulate, and then congruent, and then we're going to draw on this little picture here. So I'm going to zoom in. This lesson pretty much feels like review. We've touched on a lot of these concepts that are just presented in a slightly different way. Converse of corresponding angle postulate, what that means is if your corresponding angles are congruent, so if this angle is congruent to this angle, then you can say that this line is parallel to this one. So the converse of the corresponding angle postulate means that if those two angles are congruent, then you can say that the lines are parallel. So the next one, converse of alternate interior angles theorem. So we learned at the beginning of the chapter that if you have parallel lines, your alternate interior angles are congruent. The converse is, okay, if your alternate interior angles are congruent, then you can say that these lines are parallel. And what goes in the box? Parallel. And then alternate exterior, remember those are angles on the alternate side of the transversal on the exterior of the parallel lines. If your alternate exterior angles are congruent, then you have parallel lines. Then this line is parallel to this one. And then last but not least, we have the converse of consecutive interior angles. This is the one that's supplementary, so these add to 180. Consecutive interior angles are on the same side, on the interior of the parallel lines. The other name this is sometimes called is converse of same side interior, so just make a note that if you see same side interior, it's that same thing with which consecutive means right next to same side. Okay, we get it. Those two angles are supplementary, so they add to 180 degrees. Okay, next concept, parallel postulate. This postulate states, okay, if you have a line and then you have a point that's not on that line, there is exactly one line that's parallel to this line that goes through that point. And we can also see that they have a construction here. You'll never have to actually do like a whole construction from scratch, but often they'll ask you questions about this construction and say, okay, why is this line parallel to this one and why does this construction work? Well, the reason why it works is because this angle is the same as this one, and if you have corresponding angles equal, then the lines must be parallel. So if you get questions on a construction like this, that's normally what it's referring to. And then the next theorem, converse of perpendicular transversal theorem. So this is saying that if you have a line and it's perpendicular to this transversal and it's also perpendicular to this line, then A must be parallel to B. So this is parallel. Okay, we're going to flip to the next page, the back side. So you'll see that there's actually two sides here. We're only going to do this side, and then we'll do the proofs tomorrow. So we're just going to finish this off. It should seem pretty easy for you. Okay, so using the given information, which postulate or theorem would you use to show that R is parallel to S? Okay, so line R right here, parallel to S. We look at the relationship angle 4 and angle 8. Those are alternate exterior angles. So we could use the converse of alternate exterior angle theorem to prove that those lines are parallel. So that's what we're going to write. Converse of alternate exterior angles theorem. So you pretty much just have to identify the relationship, and if it's multiple choice, you could easily figure it out. Then next one, looking at 2 and 6, looking at their relationship, they are alternate interior angles. So you would use the converse of alternate interior angles theorem. Number 3, it says 6 and 7 are supplementary. So that would be the converse of consecutive interior angles theorem. And then number 4 is a bit of a tricky one, but it is a situation that comes up pretty often. It says, okay, 3 and 5 are congruent. And we can see that they're vertical angles. Yes, they are congruent because they're vertical angles, but do they prove that line S is parallel to line R? Well, 3 and 5 are right here, and they have nothing to do with line R over here. So yes, they're equal, but they don't prove that those lines are parallel. So we're going to say no. Vertical angles don't prove lines parallel. Okay, and then 5, 6, and 7 are pretty similar. It says, is it possible to prove the lines are parallel or not parallel? If so, state the postulate or theorem you would use. If not, state that it cannot be determined. So number 5, it shows us these two angles. It gives us their measurement. These are consecutive interior angles, so they should add to 180. And if they do, then those lines are parallel. So I'm going to add 122 plus 58, and I get 180. So yes, these add to 180, and if consecutive interior angles add to 180, then we can say that this line's parallel to this one. So because of the converse of consecutive interior angles theorem, those lines are parallel. And the next one, it doesn't give us any numbers, but it does show us this symbol here. This symbol means that those two angles are the same measure. They are alternate interior angles, and if alternate interior angles are congruent, then these lines are parallel. So, converse of alternate interior angles theorem. And then number 7, when we look at those two angles, they don't have a relationship that we've identified, but we can look at what else we can figure out. This angle is supplementary to this one right here because it forms a linear pair. So let's see if we can figure out this angle measure. So I'm going to do 180 minus 92 to find this one. And I get 88 degrees, so this is 88 degrees. Okay, well, now that I know that that's 88 degrees, alternate interior angles are equal. That means that these lines are parallel. So I can then use the converse of alternate interior angles theorem. And now we get to doing some math, which I know you guys like. So based on these relationships, we are going to solve for x in the following problems. It says find the value of x that makes the lines parallel. Well, here for number 7, we see that this is 90 degrees. If these two lines were parallel, then this would also be 90 degrees. And that means 16x minus 6 would equal 90 degrees. And we can solve for x that way. And then from here, just go ahead and solve. And x equals 6. For number 8, we have corresponding angles, and if corresponding angles are equal, then these are parallel. So that means we can set these equal. I did assign one of these assignments on Khan Academy this week because it does say that there's going to be at least one of these questions on the quarterly assessment. So from here we solve. Then number 9, same idea. Our corresponding angles are equal, and if they're equal, then these lines are parallel. So we can set these equal and solve for x. Was I able to do 108 divided by 6 in my head? No, I was not. I just remember it from doing it 4 times today. And then last but not least, this last question here, like if people make mistakes, this is where they make mistakes. Most of the time we're setting things equal, and it's so easy to get in a habit of that, but they aren't always equal. In this case, these are going to be supplementary. They're consecutive interior or same side interior, whatever you want to call them. So they are going to add to 180 degrees. Now, if the angle pairs and naming the angle pairs isn't your thing, you could easily look at this and say, okay, that's an acute angle and that's an obtuse angle. There is no way that these are equal, so therefore it must be supplementary. Whereas over here, you can see that those two angles are both obtuse angles. They're most likely going to be equal, even if you couldn't remember the whole like corresponding angles postulate. But here, it's obvious that those two angles are not equal in measure. What we do is we actually add them and put them equal to 180. So it should be 6x plus 20 plus 4x minus 10 equals 180. And then we can solve for x. Then we're done. I am going to go over a couple problems on the homework just so nobody gets stuck. So I'm going to move over. I'll project this in a second if you're still copying. Hold on.